Good afternoon. Do you folks like monitoring? No, who said no? Well, too bad. You're going to see a lot of it. All right. Welcome to Kubernetes-Defined monitoring. The problem that we are going to tackle today is, again, monitoring. So let me share in 5 seconds what monitoring should be like. Monitoring should be like this. You have your very fancy infrastructure, and you should essentially pipe out from your infrastructure a bunch of metrics from every layer of your infrastructure. So lower level infrastructure, application, processes, custom metrics. Then you should push all these metrics to a nice data engine that does all sorts of aggregation, metadata collection, trending, patterns, stuff like that. And then as an output, as an end user, you should just get a very nice set of unicorn dashboards that remove all the noise that you might have in your infrastructure and really focus on the things that help you do your job better. What happens in reality, though, is that most of the time, your unicorn dashboard gets butchered because in containerized environments, monitoring is much more challenging. And we are essentially going to talk a lot about this. So we at Sysdig have a lot of customers who tackle these problems of monitoring. So we started to come up with a few best practices that we think are really, really accurate, and because people in the field adopted them a lot. And so I'm going to share these best practices. Then I'm going to share how these ideas can be essentially implemented in a modern monitoring tool for container. And then I'm going to share some essentially more visionary proposals for nice improvements to the current monitoring workflow. So it will be interesting. For the most part, I'm going to use tools from the Sysdig ecosystem. So I'm going to use the open source system troubleshooting tool Sysdig, and then Sysdig Monitor, which is our distributed infrastructure monitoring troubleshooting tool. Why? Because they are very awesome, but don't take this talk as a pitch essentially for these tools, because it's absolutely, everything that I'll say will be absolutely in a completely vendor neutral way. So as long as your favorite monitoring tool respects these principles, you'll be fine. So why your unicorn dashboard get butchered? They get butchered because things are fundamentally more complex in a containerized environment. So you take a simple infrastructure like this with 3 basic building blocks, so a database, a web server, and a caching tier. And when you deploy it in your infrastructure, you get something like this, where you have the different components of one instance of your application live in separate, essentially are hosted in completely different nodes, and so they communicate with each other using all sorts of virtual networking layers that, of course, hinder to some degree the visibility. And then you also are going to deploy multiple copies of the same application, and so you end up with a big mess, and your monitoring tool needs to be aware of all this mess, needs to be aware of how to properly make sense of this data so that you don't have to do it. All right, back on. So how does that impact monitoring from a practical point of view? We identified 4 things that are harder to do in a dynamic and flexible containerized infrastructure. First of all, getting the data. This is the very first step, and it's harder because, of course, you have the containers in the way. I'm going to essentially analyze much deeper each of these points. The second one is making sense of the data. So once you are able to finally extract this data from your containers, how can you organize it in a way that allows you to see what is the health of your application? Then we have essentially the troubleshooting, because, again, monitoring is very much connected to visibility. Visibility is the enablers for the monitoring and for the troubleshooting as well, so they are very connected. And then there's a 4th point that we started seeing a lot at Sysdig, which is the people. So microservices enable teams of people to stay very close to their infrastructure and follow the whole application for the whole life cycle. Because it's extremely easy to deploy an application on Kubernetes. So most of the time, the team of developers that write the application then take care of everything, take care of the deployment, and they want to also take care of the monitoring. And so there's this kind of affinity between teams of people and microservices and application that needs to be monitored. So for monitoring, this will be taken also into account. Let's start with the first item, getting the data. This is, of course, the very first step. Containers are great because they are simple, they are lightweight, they are isolated. But for these same exact reasons, when it comes to visibility, these exact features become a big pain in the butt. Because now you have this further level of isolation between you and your containers, between you and your applications, which are essentially the container. And in practical terms, it means that extracting stuff, it's much more difficult. And so how can we get this data? What are the best practices in the industry? We have seen essentially two models for extracting the data out of the container. This first model essentially leverages the pods in Kubernetes. So here we have two containers that are, of course, wrapped inside pods. And this container somehow needs to be instrumented. So some metrics need to be extracted from this container. So what happens is that typically you deploy a monitoring container, a Sidekick container inside each pod so that this will share the network namespace, some volumes, and the monitoring namespace, maybe by pinging on localhost, it can extract a bunch of metrics from the container that you're looking for, and then this one can push it somewhere else, or it can just expose them to another port so that you can use another monitoring tool that does the pooling. This works very well. It's a very elegant model. The main issue with this is that you really need to add one more piece of infrastructure every time you need to monitor something. So at times, it can get a little bit cumbersome, but it's a completely reasonable approach. Another one, which is the one that we tried at Sysdig, is essentially following the principle of not having the user to modify the configuration of his infrastructure at all. And so what happens is that Sysdig taps at a much lower level. With a little kernel module, we intercept all the system calls that all the containers, the processes in the containers are doing, and also the processes outside the containers are doing. Then we take this rich stream of data, we correlate it with the metadata that applies to each container. So if I see Apache doing a system call inside container 2, I then know that container 2 is part of this pod, this deployment, and this namespace. And so I correlate all the metrics with all that metadata. And that turns out to be a very powerful approach. Which are the advantages? The advantages is that, obviously, it's very much plug and play. You don't need to modify anything in your infrastructure so you get immediate value. And then you can also use it for monitoring things outside your container, so it can be infrastructure-wise. The disadvantage, of course, is that you can see how it can get a bit invasive. So especially if you're concerned about security and stuff like that, it raises some other concerns. But for the most part, this is what we settled at Sysdig. We find it to be a very, very reasonable approach, considering the value that you get. So after you get the data, it comes to the other part, which is making sense of this data. This is probably the most important slide of my talk. I think all these items are extremely relevant. And so these are the guidelines that you should adopt when you get the data to make sense of it. So let me explain them. The first one is you should not be involved in monitoring instrumentation. What does it mean? It means that you should not come up with clever ways to extract metrics from your containers or instrument things in one way or another. Your monitoring tool should provide you a very user-friendly and very easy to use and as automatic as possible framework to collect metrics at all degrees from your infrastructure, from your application, from custom metrics. So you shouldn't really get into the business of doing instrumentation, because that's probably, again, not part of the value that as a company you provide. The second item, closely related to this, is that you should not be involved in producing anything that is not a custom metric. So a while ago, we're talking to a customer. This customer was super happy, said, wow, I wrote this script that I run inside my container that's using essentially a JMX command line tool. I'm scripting it, and I'm extracting Java heap usage metrics, and then I push them in my monitoring tool. No, that's horrible. If you find yourself spending your time writing a script to extract something as basic as a Java heap usage metric, you're doing it wrong. Because even if it's inside containers, and even if it's easier, even if it's more difficult to extract JMX metrics inside container, I understand that. But still, your monitoring tool should do that for you. So the only time where you should be involved with custom metrics, is when you really need to produce them from within your code. So you use Sysdig or use whatever other protocol for producing custom metrics, and you want to track things, I don't know, the queue size of your transaction dispatcher pool or something like that, stuff that is really relevant with the code. And that's the only time where you need to do that. The third point, which is probably the most important among the most important points, is that every metric should be tagged. When you're dealing with containers, since they are so dynamic and things get rescheduled all the time, just having access to the metric is not enough. Unless you are able to put those metrics into the right context and in the right perspective, they are fundamentally useless. Let me show you what I mean with a practical example. So this is Sysdig monitor. This is our essentially distributed infrastructure monitoring tool. Here you can see a table where I see a bunch of containers for my infrastructure. For each container, I don't know, let's get one WordPress, for example, like this one. I can see the CPU, very basic system metric, and that's cool. But in itself, this doesn't tell me anything, because what does this container mean? Where is this, what application this container is part of? So if you're able to correlate this metric in the proper context by applying all the tags that apply to this container, which in the case of Kubernetes is all the hierarchy of pod, deployment, and all that, you'll get much more value. So if instead of looking at this flat table, I start and I slice and dice my infrastructure by namespace, so I see that I have a production namespace that has a WordPress deployment, that has 2 WordPress pods inside it, and then I get the CPU for each one. Now these metrics make sense, because now I'm able to compare this CPU in its right context. I'm able to compare it with the other members of the group, and I'm also able to get aggregated metric at the microservice level. This is a metric that must be automatically generated by your monitoring tool. Your monitoring tools should automatically do that. And then you can also dig much deeper. For example, in this case, since we are using the system call interface, we are able to capture, for example, layer 7 payloads. So here you can see for my whole microservice, all the HTTP requests that are being done with the response time and all that. And this is all possible because we know the monitoring tool automatically correlates the HTTP request with the metadata that applies in the context of the cluster orchestrator. So again, if there is one lesson that you need to take away from this whole talk, is use tags extensively. And the other point, always regarding tags, is that you should not be in the business of manually tagging your metrics. If you think it's a good idea to push your custom metric from your code, and then with whatever SDK you're using for pushing metric, manually applying it, all the tags, for example, I'm pushing this custom metric, and I'm gonna put the pod, I'm gonna put the deployment as a tag. No, your monitoring tool should do that for you. Why? Because one, it's extremely error prone to, being in the having to carry the burden of tagging each metric yourself, and two, it's extremely difficult because most of the time, in the point in the code where you are pushing your metric, you have no idea in what namespace you're running, because the namespace is here, and you're running an application inside a container, and you have no way to do easily a self-reflection on all your infrastructure stack to navigate all the metadata. And pushing it down, it will be extremely difficult. You have to keep a lot of states. So your monitoring tool needs to absolutely take care of that, 100%. Very important. The last one, obvious, is that you should collect everything and really try to not filter anything up front. So I like to compare this with the world of logging. Like when you do logs, you typically log everything. And then when you need to do a troubleshooting, you use grep, you use Elasticsearch or whatever you want to just look for the stuff that you need at that specific point in time. Same thing should be for metric. I know that this means that, especially in today's environment with a lot of applications and rich frameworks and all that, this means having your monitoring tool support a massive scale. That's fine. It's absolutely worth it. So this is how you make sense of the data. Again, I like this slide very much. We learned this essentially on the field by experience working with customers. So the other item, again, as I said, is essentially troubleshooting, which is very, very related to monitoring and visibility. This is just a random screenshot that I got from GitHub on Kubernetes, where you can see how when you need to do troubleshooting of a containerized applications, you always end up with some pain because either you are running a very stripped base image and you don't have the troubleshooting tool that you might want, or the troubleshooting tool that you might want is not cgroup aware, or there's a weird proc file system layout and so it won't work, or you have to cross the network namespace or something like that. So everything that I said up to this moment completely applies also to the troubleshooting field. So your troubleshooting tools should be completely aware of the fact that you're troubleshooting a dynamic and flexible infrastructure in a containerized environment. So what does this mean? You have probably seen this demo before, so I'll keep it very short. That is always very fun. So this is an infrastructure that is running on my laptop. As you can see, I have 2 namespaces with a bunch of pods. So there's enough raw material to do some serious troubleshooting. So I'm going to use Sysdig. Sysdig is essentially a curses-based UI for our Sysdig command line troubleshooting tool. It has the same features. It's just very easy to look at. And so here, when I open it, it shows me all the processes that are running in my system. And that's fine. But since we are doing container troubleshooting, I'm going to switch a view to my system, and I'm going to select containers. By looking at containers, now I'm seeing all the containers in my system along with the resources that they are consuming. Good, but very basic. Let's filter for one container. So let's search Redis. It shows that we have 2 Redis containers running in my machine. So let me select one, for example, this one. And if I press Enter, I drill down into the container. And this now will show me the, sorry, I entered in the one that keeps hold of the network namespace. So in this one, I see essentially the Redis server process. So I can see how many resources it's consuming. But while we're inside the container, let's take a look maybe at the network connections that this Redis process is generating. And again, this is just across network namespace, because we look at things from a system call point of view. And while we are at it, wouldn't we like to see the actual content that is being transferred on this network connection? So I can press F5 and I go into echo mode. And this will show me the Redis transactions that are going on the wire, essentially, on the network connection. And stop for a second and think about how I did. I didn't use any TCP dump or anything overly complicated. I just opened Sysdig from outside, and this, by fetching all the system calls and correlating them with the proper metadata, in this case a simple container name, was able to show me all the content of the I/O. This is very powerful. I use it in production myself all the time, so it's very good. Although there is still one thing that that kind of bothers me, which is I've done a navigation essentially starting from containers, but what do I know about these 2 containers? I don't know which one I was really interested in, because again, as a Kubernetes user, I reason in terms of Kubernetes abstraction. So instead of starting my troubleshooting while looking at the containers, why don't I start it by looking at the namespaces? Even if I'm using a low-level system troubleshooting tool, I can start by my troubleshooting by looking at the Kubernetes metadata. So here I'm using the production namespace, and I can jump into it. And this will show me the pod in this production namespace. And I can see that now I have just one Redis pod in this case, because the other one was in the other namespace. So I can do this top-down approach also to troubleshooting. Let's pick something else. Let's pick something interesting. This Java app pod. I can enter into this one, and I can see that there is just one container. I can enter into this container, and I can see there is a Tomcat, and then there is an Nginx that probably does something, I don't know, probably SSL offloading or something like that. And if I pick, for example, the nginx worker process, I enter into the process, and now I'm seeing the threads that this thread is essentially made by. And while I'm inside here, I can look at the activity that nginx is doing. And notice how I'm looking the individual HTTP requests and responses from outside the container. Again, pretty cool. But don't let yourself be fooled by the fact that I'm just looking at network activity, because let's switch to something else. While I'm in this nginx, let's look at the files that nginx is touching. We can see that nginx is doing a constant amount of outbound I/O towards var log nginx access.log. Let's see what is the content, F5. This is showing me the log entries as they are happening in the system, and while I'm outside the container, so I didn't have to do a docker exec, an nsenter, and this is really cool. So I like to think of Sysdig as a TCP dump for your entire I/O of the system. It even works with pipe. If you do a pipeline in shell, if you do a cat foo pipe something, with Sysdig you can see what's been transferred on that pipe. Really, really cool. And then I can also save all this information to a trace file, and then I can work on this trace file offline with the same workflow that I would use now. So this is a workflow that we borrowed from the network world. TCP dump and wires are awesome tools. And we said, OK, let's apply also this to system troubleshooting. So this is what I can say about troubleshooting. Last point, and then we'll be done, was about the people. As I said earlier, microservices really enable teams of people to stay close to the life cycle of their applications. So we think that monitoring should definitely be part of this equation. So monitoring should enable teams and should enable people to stay close to their microservices. So at Sysdig, we experimented with this concept of teams. So you have your monitoring tool that from the left, it ingests a massive amount of metrics. From the right, it ingests all the service metadata. So in this case, from the Kubernetes API server, it watches all changes and constantly correlates all these metrics with the Kubernetes metadata. Then, and this is the trick, if we know that one team owns a subset of the infrastructure, it could be a namespace, it could be a deployment, it could be something else, something defined by just labels, we can choose to route the subset of metrics that apply to this team to a different entity from a monitoring perspective, which means different set of logins, essentially a sandbox for monitoring, so that people can use a big cluster. That this can be shared across multiple teams, and every single team can have a unique view of the infrastructure as they like it. And this can be good to reduce noise, reduce clutter, but also provide proper isolation, because maybe I don't want my developers that run the staging container to see the SQL query that my production server is doing against the credit card. With this, you can achieve it. So with teams, again, designed to reflect people, integrated with Kubernetes, support isolation and customization. But what I want to show you now is this other item, which is self-service. So at Sysdig, we said, OK, this concept of team is pretty cool, but you have to create teams manually, right? Every time you deploy an application, you go in the UI, blah, 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 and you do this, or also via API. But wouldn't it be nice if we could bind together really infrastructure definition and monitoring definition? And so we started with this experiment. So if you remember my WordPress deployment, it looks something like this. So it's just a standard deployment. And then I have just a very standard container. I even have a password in clear text passed as an environment variable, horrible. But then I have in the annotation sections, again, the annotation is this essentially section that Kubernetes provides for pretty much any resource, which is arbitrary key value pairs for arbitrary consumption. And so we said, can we use the annotation to put a little information about what we like in terms of team? And so I'm saying, OK, put this annotation that says, I want a team for this service, and these will be the members of the team. For this team, I want these dashboards, because I know that they're going to be useful for them. Then I want the alerts, because again, alerts is very important. I want them to go to this email address. And then I want the alert. I want a simple alert that will alert me if I get a slow response time, which means if over a sustained period of 60 seconds, the average of the response time goes above 500 milliseconds across my whole service. Then I have another one, which says maybe the CPU. It's also a very good thing to say, which is alert me whenever the CPU across any container. So this one is different. This one is not doing any aggregation. This one is taking a look at each individual container that is part of the deployment, goes above 80%. When I submit this to Kubernetes and when I deploy this, our Sysdig in user space that is listening to the Kubernetes API server from watch changes will read these annotations and will automatically create a team definition for us that then we can consume in the UI, and we'll keep it in sync with the annotation. So if I change the annotations, everything gets reflected to the UI. So if I go to where I was before, this is what we call the root account. So here I can see everything. But if I switch over here, I can see that I have two teams created automatically because I deployed two versions of my WordPress deployment, one in the dev namespace and one in the production. And if I switch to this team, now I'm just seeing these two containers that are part of the deployment. And this is completely dynamic. If one container goes down and gets rescheduled, essentially our monitoring system will recognize that a new container comes up and shares the same set of deployment and stuff. And so we'll route it to the correct team. And so I can do a basic exploration like this. I can, again, slice and dice it by the metadata. So I can see production, WordPress. And I can, again, do the same sort of troubleshooting where I can see all the system metrics and everything that I care about. And then I also have dashboards that are automatically created in this concept. I created a MySQL basic view where I'm able to take a look at all the SQL requests that this WordPress deployment is doing. And this is all created automatically based on a template. So I just provide the template of the dashboard that I want. And then this is like a stamp that gets replicated every time I create a new team with those annotations. Same thing with alerts. With alerting, I have all my alerts created automatically with the proper notification channels created. So a team overall looks something like this. When I go to teams, I can choose, hey, I have a big cluster of Kubernetes, but for this team, whose members are these ones, just show me all the containers that satisfy this criteria, which in this case is namespace and deployment. I could choose anything I want, assuming I'm the administrator. And this really provides a lot of value. This really provides isolation, because then, if you have a user just belonging to the team, it won't be able to see the other container or the metrics on the host. So there are a lot of use cases that this enables. Again, dev versus production split, team per microservice, or mini internal. We know that a lot of companies use Kubernetes really as a some sort of platform as a service for their various teams. So this is also useful. And so very generally, actually the implementation is very straightforward and trivial. But the concept of not only having infrastructure as a code, but also monitoring as a code is really appealing because again, it just is. It just is. And this is all I had to say. These are some very interesting pointers, especially if you want to try out these latest features that I just shown. This last link over there is a very recent blog post that is also a tutorial, so you can go and try it out. It's very, I'm sure you can see the value of this. And again, as I said, not a completely vendor agnostic, so if you have a monitoring tool that's able to achieve these things, cool. But again, the principles should be considered, should be kept in mind. This is all I had. Thank you for your time.